During this chapter, we're talking about experimental design, but not just experimental design in general, but rather also talking about a between subjects design. Okay, so next week we'll be talking about a within subjects design, which will be then differentiating between the two. So in any experimental research, obviously the researcher is manipulating the independent variable and then looking to see how the independent variable impacts the dependent variable. Okay, so then they measure the dependent variable for every single participant. Well, in an experiment, basically what we're trying to determine is the cause and effect relationship, okay, to determine that whether the differences exist between the different conditions of the IV. Okay, well, for between subjects design, basically what you have then is independent groups for each condition. So you would have only one score for each participant. So for instance, if I had two conditions, let's say my IV is meditation, okay, actually no, I use that one all the time. Let's say my IV is, it's just so easy to do something like that. Exercise, okay, and I ask one group to, or not, and my two conditions are people who exercise daily and a group that doesn't exercise at all, okay, those are my two conditions of my IV. So I would have two separate groups. One group that I would ask to exercise daily, and obviously I'd give them more information on what they need to do, and the other group that would not exercise at all. So here in my between subjects design is that there's only one score obtained from each, and they're independent groups. So the structure, here's an example, okay? So I have a sample of participants that have participated in my research, okay? And then I divide them into three equal groups, or as equal as possible. Here's one group, they would get treatment condition 1. Here's another group, they would get treatment condition 2. And here's another group, they would get treatment condition 3. So again, each group is only getting one of the conditions. Now, what are the advantages and disadvantages of a between subjects design? Well, the one thing is that each individual score is independent from all other scores, meaning that because they were only exposed to the one condition, okay, their score, their DV score, is only impacted, well, hopefully, by that one manipulation of that condition. Okay, it's not influenced by any other conditions that they might have been exposed to. The individual score then is not influenced by, like practice effects or experience that they would have gained from being in other treatment groups. Okay, so for instance, let's say that, I need to come up with a good example. Let's say that I am maybe manipulating their motivation. Okay, and so I have a high motivation group, a medium motivation group, and a low motivation group. Okay, now if I am only exposing them to one of these motivation groups, and let's say in the high motivation group, I like pep them up just based on what research says that like really motivates people, and then I have them take some cognitive performance task, I know that their performance on that cognitive performance task is only impacted because they only did it that one time. But what if they were in all of the conditions, right? What if it wasn't a between subjects design, it was a within, and they were all then in each condition? Then if every time they took that cognitive performance task, they would basically have practiced. It would have just been, another time they've done it, so they've had experience to do it. Also, sometimes if you've been in an experiment for a really long time, there's boredom or fatigue that could be impacting their performance. And also contrast effects that result from comparing one treatment to another. We don't have that because they're all independent groups. But some disadvantages. The one big one is that you need large sample sizes. Because let's say that we have three conditions, right? We have a high motivation group, a medium motivation group, and a low motivation group, okay, or no motivation group. We need the same amount of people in every task. And when you're doing a study, right, you need a good solid number of participants. So let's say that we want 30 participants in each condition. That means you need 30, 60, 90 participants, right? So you have to recruit quite a lot of participants. The other downfall is each score that is obtained is for each unique individual. right? And because we're all unique, we all have our own personal characteristics that are different from everybody else, we could have individual differences that are impacting the scores across. And if we don't vary or randomize those individual differences well enough, then they could become a confounding factor. Okay, so individual differences as confounding variables. The groups in a between subjects experiment must be as similar as possible, except for that IV, that independent variable that is distinguishing them. Meaning that the group in, or the people in group 1 and in group 2 and in group 3, we're trying to make them basically as even as possible in all personal characteristics. And the only thing that differs really across them is the condition, the, let's say, high motivation group, medium motivation group, and no motivation group. If the groups are different, okay, then individual differences could potentially become a confounding variable. So for instance, what if one group just already has higher motivating individuals anyway? Okay, or what if one group has higher educated individuals? Or what if one group is more open to experience, or whatever it might be? That could become a confounding variable and could actually be influencing our results rather than the IV impacting our DV. So here's just showing you age as a confounding variable. Okay, so let's say that we have treatment 1 group. Okay, so this is one group and this is another group. This group is getting one treatment and this group is getting the other treatment because these are our IVs. Okay, if this group is relatively older participants and this group is a group of relatively younger participants, then the scores in one group could potentially be different from the other scores in the other group, not necessarily caused by the treatment, the difference in the treatment, but potentially caused by the age differences. And now age has become a confounding variable because now we don't know whether it was the difference in the DV that was caused by the IV or difference in the DV that was caused by the age differences. All right, other confounding variables are individual differences in terms of like characteristics. So like I just said, participants in one group, they might be older, smarter, taller, higher socioeconomic status, more educated, more open to experience, more traveled, whatever it might be that could be impacting it. Another one are environmental factors, okay? Treating or testing one group in a large room versus testing another one in another group, in a smaller room or a smaller group, testing one with a male experimenter versus another with a female experimenter, okay? Like basically the domain around them, you want to try and keep them as similar as possible. If you're showing one group a video and that's like how you motivate them, and the other group that's not getting any motivational, like factors, they're the no motivating group, it's good to keep them as similar as possible. Meaning like if one watched a 20-minute video on, motivation, then you kind of want to get the other one to watch a 20-minute video, but that's neutral, that has no motivation. So you're really trying to keep them as equal as possible. So the researcher, you're trying to control the groups so that they are as equivalent as possible, like I just mentioned. Okay, so the separate groups, they must be created equally. We want to treat them equally, okay, and hopefully they're composed of equal individuals. Now you want to say, well, how do we do all this? Well, we do it by 3 primary techniques. One, random assignment, which I'm sure you've all talked or learned about, okay? Randomly assigning them to a different condition. That means that each participant has an equal chance of being in any of the conditions. Or you could match the groups, okay? Let's say that you believe that age could be a confounding variable, and therefore for every, like young individual, let's say a young individual from 20 to 25, the next time you get another individual of 20 to 25, you're going to put them in the other group. Okay, or maybe let's say you want to match them on gender. Okay, so for every one female you put in one group, you're going to put the next female in the other group, or male in one, so you're trying to even them out. The other way you can do this is by holding variables constant. Okay, so sometimes it's important just to try and weed out everything. So in this case, an example is maybe you suspect that gender could be a confounding variable, and therefore you just eliminate gender as a variable and you just choose to accept females, males, non-binary, whatever you choose at the moment. An example of this is I was a part of a study that was looking at adolescent girls in terms of how their brain activation is changing for those who are already experiencing anxiety and depressive symptoms versus those who are not? Well, because we started testing them around the ages of 14 and 15, well, as you know, puberty is hitting, menstruation, things like this, and therefore we wanted to completely eliminate the possibility that gender is a factor in this. So we just did it on all females and didn't even incorporate males. So this is an example of holding variables constant. All right, next week we'll talk about within subjects design. So hopefully this gave you a little bit of a little taste of between subjects. Bye.